What are evolutionarily stable strategies?
In many cases, it's kind of clear what's the best thing for an individual to do, the best thing it can do to increase its survival and reproduction. But there are times when what's the best thing to do depends upon what other individuals in the population are doing, what, in particular, the majority of individuals in the population are doing. A hypothetical example we could call fishers and pirates. And I'm talking now about some kind of birds, where there are two ways of getting fish. These are seabirds. Either you can fish for fish, you either dive into the sea and catch fish, or you hang about waiting for a bird that's caught a fish and steal it. Those are pirates. And these are two ways of making a living. Now, what's the best thing to be, a fisher or a pirate? And the answer is that it's not obvious, because it depends what the rest of the population are doing. If the whole population is fishing, then it could very well be that an individual could mutate and become a pirate, because there are plenty of fishing going on and it's easy to steal a fish. So then you might say, well, a natural selection then favors piracy. The gene for being a pirate spread through the population. In a few generations, now everybody's a pirate and there's no fish. So piracy is not stable. It's unstable, it's evolutionarily unstable. Fishing might also be unstable, because if the whole population is fishing, then a mutant pirate invades. So a stable strategy is a strategy such that when all the population are doing it, no mutant individual could arise which would do better. So neither fisher nor pirate in my hypothetical sort of game is evolutionarily stable. What might be evolutionarily stable is some kind of ratio. It might be 80% fishers and 20% pirates, something of that sort. And the definition of stability in this case is when they're doing equally well. A well-known example is the sex ratio, where any departure from the stable sex ratio is penalized by natural selection. If there are too many males, an individual is better off having daughters, and if there are too many females in the population, an individual is better off having sons. And so the stable ratio is 50-50, or strictly speaking, it's 50% investment, economic investment in sons and economic investment in daughters. So an evolutionarily stable strategy is a strategy which cannot be bettered by any other strategy, provided that everybody else in the population is doing it.